right, so good morning, everyone.
Morning.
I mean, it's morning somewhere. I'm Alessandro, he's Rob. We're here to talk about AlgoKit. We have a bit of backstory of how it came to be, a few announcements to make, and then at the end, whatever questions you have, throw them our way. We're here, so we're happy to reply.
We're largely here to just have fun, really.
Yeah, exactly. Let's enjoy, let's learn some things. AlgoKit Story.
How did it start, Alessandro?
Well, I got hired by John September 22, and like 3 weeks after that, we've met in Singapore, and we were like, okay, we have to do something about our developer tools. I'm a former engineer, and during the interview process, I was kind of embarrassed because I couldn't stand up the development environment. I'm like, that's okay, I'm not too dumb. What's going on? So we started in Singapore with the core concept of let's make onboarding easy. We've set ourselves the target of about 5 minutes would be the gold standard. Less than 10 minutes is perfect.
Yeah. We wanted to make it so that someone could start from an empty machine that they hadn't done any Algorand work before, and within 5 minutes be doing, deploying with breakpoint debugging of a smart contract that they can then develop on, right?
Yeah. Mind you, pending Docker, which on Windows maybe hit or miss.
We hand wave over them.
Yeah, exactly. But so the first 1.0 release was us shaping up Beaker in a bit more stable way and setting up the development environment quite quick.
Yeah. And so once we've done that, the next question was, well, hey, we can now develop smart contracts a lot easier, but consuming them was still really painful.
Exactly. So after that, we focused on the client generators, and utils became way bigger. So all of a sudden, you have Arc4 compliant smart contracts that generate a client that give you pretty much intelligence whilst interacting with it. So it's not scrambling in the dark or dark with extra steps.
And type safety, so that you can use the primitives of the programming language that you're using, rather than having to construct esoteric byte arrays of data to pass into and cross your, sacrifice a goat and cross your fingers that the call's actually going to work or do what you thought it might do, right?
Yeah, exactly. After that, we said, all right, we've kind of covered the smart contract bit, onboarding. You now can interact with the front end. We baked into the React template use wallet by Transaction Lab, which my huge gratitude to you guys because you're saving a lot of people headaches. Then we started focusing on what is the end-to-end experience of maintaining an application. We've seen plenty of repos that had handmade scripts about mass opt-in, batch transfers, and all that. So we started thinking we should probably start baking those in.
And then also we wanted to make sure that it was easy to deploy smart contracts. It was easy in those situations where you had a weird problem and couldn't quite figure out by reading the code to actually do breakpoint debugging of the smart contracts, and basically just trying to get this sort of seamless end-to-end development experience, everything from you get started to the things running and you're operating it, like working in a really cohesive way.
Yeah, exactly. And after that, we've focused on, okay, there was, since the beginning of my journey here at the foundation, whenever you mention PyTeal to people, you'd see them run, hide, all of the above. I mean, PyTeal was brilliant, but there had to be an easier way. We saw Fergal's Tealish, which is a wonderful alternative to PyTeal. We saw plenty of stuff. Joe was starting to build TealScript. So we saw the potential of higher level languages done right, and decided, okay, we have a Python first environment, so let's start to actually do Python. And Python the real way.
Definitely. And the idea behind it was, how can we make it so that you don't need to spend like weeks trying to understand how to build a smart contract, or go and have to hire specialized people? How can we make it so that everyday developers that are new to Algorand can become productive very quickly and build smart contracts that are correct, which is obviously really important, right? Like in the smart contract world, a lot of the time when you write the code and deploy it, that's it, it's immutable. And quite often, these smart contracts are protecting large sums of money. So correctness is really important, but we just wanted to open it up so that like more developers can actually do this stuff, right? It's not voodoo magic anymore.
And now at this point, there's a rocket, which is what we're announcing today, the few things we're announcing today. So on Python and Puya, you might have seen a PR merge yesterday and a release cut. And we're happy to have boxes, a sane boxes API representation. Apologies for the delay. We wanted to cut it for V1, but we went down a rabbit hole. We're also working towards how can we have boxes that work both on the Python frontend and the future TypeScript frontend. So we decided to take a bit more time on that.
Yeah,
but it's pretty nice.
Yeah, definitely. And like, this is just one little snippet. Like the actual box support's quite like extensive. Yeah. This is one tiny part of it, which is just using a box map. But you can see we've been able to do things like, transaction.sender in self.mymap, so we can incorporate the normal Python idiomatic primitives into the programming experience. It just makes the contracts terser, it makes them easier to read, especially if you're a Python developer in this case. But yeah, there's so many other parts to this. You can store single values, you can store lists, and you can actually create them dynamically as a local variable and then pass them into subroutines and that sort of thing as well. So there's some quite like interesting kind of programming dynamics and stuff. And we're excited, A, to get feedback from people, but B, to see what people actually do with it, right?
Yeah, exactly. It's, as always, if you have feedback, if you want us to improve on anything, PRs are always welcome, but we're also on Discord. After this, there's unit testing. A lot of the key reasoning behind the approach that we had in structuring Python language with semantical correctness and all of the above was that all of a sudden we can use already existing Python tooling, debuggers, linters, and all of that would work out of the box. And of course, with that, unit testing is a key important thing because PyTest is half decent testing suite. Seen better,
really
done worse. No, but it's as a default standard testing suite. It's really
not bad. Yeah,
I mean, it's better than just. Let's put it this way.
And I guess the mental model we had for this one was, okay, today or before this, the way that you could test a contract is you would write some code that deploys the contract to say local net or maybe another network, but generally probably local net, and you would craft a call, hopefully using a type safe generator, so at least it's type safe, send it to that network, get the result back, do some sort of assertion on what happened, maybe call the contract again to get the global state values or whatever it might be. And that's fine. The great thing about that is you have a lot of confidence because you've done an end-to-end test that verifies that when that contract ran against the AVM, certain semantics occurred, right? So, and we're certainly not saying with this that you wouldn't still do that type of testing. But the problem with that type of testing is it's in an order of magnitude of seconds. And so if you have a lot of tests that you want to write, or in particular, if you've got maybe smart contract methods that have really complex logic in it, and you want to do things like property-based testing or combinatorial testing to make sure that all the code paths 100% do what you want them to do because you're securing $1 billion worth of value or something like that, then you kind of want to be running like thousands of tests against a single method. And thousands of tests times by a few seconds is a really, really slow developer feedback cycle. It's not a pleasant experience. And so the goal of the unit testing support that we've released last week, is, and it's in beta right now, so we're very open. We want feedback. We want people to use it and tell us what you think so that we can shore it up and get it out as a 1.0. But basically, we've now got testing that you can do in the order of magnitude of milliseconds. And so that means that we can do things like property-based testing, model-based testing, combinatorial testing. And the other really, really cool thing is we are basically running it as the Python in-memory in process. And that's how we do that. So it's kind of emulating parts of what happens on the AVM. So there's a couple of implications for that. Number one, the really cool thing is you can do breakpoint debugging of your Python contract code. And I'm going to show you that in a second because it's really, really cool. And that makes it so much easier when you're first doing the logic to actually quickly understand what's happening when you execute the thing and why is this like not coming out with the value that I thought it would. Oh, I did a silly thing and put a plus rather than a minus or whatever it is. You can do that in order of magnitude faster as a developer feedback loop, which we know from experience is like it makes it so much easier and more pleasant to develop, right? Yes?
You'd be able to unwind the stack and change the stack variable. So go backwards.
Oh yeah.
Change
Well,
the
it's
stack,
PyTest, right? Like if you can do that with PyTest
Just interactive.
and VS Code, then probably yes. I haven't tried that. That's really interesting. Let us know. Like try it out. There you go. But the second implication, though, which is important to keep in mind, is it's not running the AVM, right? So the level of confidence that you get from these tests is a different level of confidence than the full deployment to an AVM. And so the way we see this, the mental model we have, is that this is a different kind of testing that you have in your tool belt, and that a comprehensive test suite that is, we would always recommend doing it in a risk-based approach. You would use a combination of the different types of test to test for different classes of errors. So this type of testing, really great for testing the nitty-gritty logic, but you probably should still do, especially if it's an important code path, the style of testing that you were already doing where you actually fire it off against the AVM. So, should we show a little demo? I'm just going to sit down. Cool. Which one? That one there. So, we've got a contract here. This is one of the example contracts in the Poya Algorand Python repository. It's a long-standing contract. I think
it's one of the first examples we made.
It's everywhere. Like I think it was in Beaker as well or something like that. It's kind of been converted between different programming languages a few times. It's an auction, right? Like we all understand how an auction works, right? Now, if I go to this test_contract method here, this is what the testing experience looks like in our new unit testing support in Algorand Python. So this is an example of a simple test. So in this case, we're doing the opt-in check. So we've got the structure we have in these tests. You don't have to follow this, but it's good practice. Is arrange, act, assert. The idea being arrange is where you set up the context for the test. Act is where you actually have the call, the unit under test, and assert is where you make any assertions about the result of that to check that whatever you thought should happen has happened. And in this case, you can see here we're passing in this context object. And this is the thing that emulates parts of the AVM and allows you to mock other parts of the AVM. And essentially, we're creating an asset, and the context object has something called anonymous variable support. So we can say any asset. So we don't have to like put values in there that don't matter to this test. We can say, just give me an asset. I don't care, like add whatever like total value and unit names. I don't care about that stuff, right? Like that's noise. We want to have these really lovely terse tests. Big shout out, by the way, to Altenbeck, who's standing at the back. He did a lot of the work here, and he did a phenomenal effort. So then we new up the contract itself. We've got the call to the actual, the method, the arc4 method in this case, opt into asset. And then here we're just asserting that the ASA value, which is a global state value on this contract, is equal to that asset, that there was an inner transaction that was an asset transfer, and that transaction had the asset receiver being equal to the address that we expected it to be, and that the asset being transferred was that asset. Potentially, we might also want to check that the amount sent was 0, because that's obviously an opt-in. So maybe there's a missing line there, but you get the idea. Anyway, more exciting. Let's look at something a bit more interesting. There's a start auction method. We want to test that. Starting an auction, there's things like a timestamp, a price, duration the auction can be valid for. We actually have to pass in the arc4 asset transfer for it. You can see here some of the stuff where we enable you to patch certain fields to mock those values so that you know what the context of this smart contract execution looks like. You can see we've done a good job, I think, of making that quite terse, but again, we're open to feedback on that. We've got the actual call to start the auction, and then we've got a few asserts. Now, the reason I'm showing you this is because in this method here, if I scroll down on the start auction method, I've added a breakpoint at this point here. So if I go to this test here, start auction, and I click debug test, then it's going to open up Python and PyTest, and my computer's running on like battery mode, so it's a bit slow. But then boom, we actually are on that breakpoint. I can hover over things like transaction sender, and you can see here we've got the randomly generated like sender address. I can hover over the creator address. I can hover over like self and see all of the like global state values. I can hit F10 and like do line by line debugging. I can hit F5 and let the test run, and it finishes running successfully. Yeah, thank you. And again, battery saver mode aside, if I run all of the examples, there's 20 tests in there. And you can see in this case, those 20 tests ran in 1.58 seconds, which is generally like the amount of time it would have taken to run one test. And what I would say is a bunch of that 1.58 seconds is Python spinning up. So the more you have, like they're all running in like order of magnitude of milliseconds. So it's very, very powerful.
So feel free to try it out, give us feedback. It's good, it's fast. And you're not using Docker, so.
I'm personally very excited because when we first started talking about algorithm Python, this is the thing I had in my head, is that what I just showed you there was like it came out of my, like Altenbeck took it out of my brain from 18 months ago and just like put it on the code editor. It's incredible.
And now on to next
the mic
item.
drop.
Yeah, I mean, I love it. Meet LoRa. LoRa stands for Live On-Chain Resource Analyzer.
Yes, it's Laura the Explorer.
Yes, exactly. Dora, we thought...
We were thinking Dora, but you know.
I don't want to deal with lawyers too much, so it's...
Yeah, there was something called Dora out there.
Yeah, exactly. So LoRa is... We're trying to make it the developer's best friend. So as you may notice, this thing will become a native app on your desktop. At the moment, we're running through some hoops to get code signing certificates to actually deploy.
I've just never seen anything quite like this. Like,
it's been
for
months.
anyone that's tried to get code signing certificates before, like you probably understand this, but like it is. How long have we been going now? Like 4 months or something? Like just bizarre.
It's fun.
Like, it's wild.
It's trying to get Apple to understand that I don't have an employee badge because we're completely remote. So it's that's. I mean, I'll send them this picture. Let's see if this works.
Why is that not going? Come on. There we go.
But
all right.
so,
here we go. So homepage.
Exactly. This is LoRa. You can point it towards mainnet, testnet, of course, localnet. As you can see, it's snappy.
This is mainnet right now.
It's snappy. It's fast.
So within a few milliseconds of a block being committed, it's loading it, and you could see all the live transactions there.
Yep.
Alessandra's just clicked into a block. You can see in this block, we've got a bunch of different transactions, some app calls, some payments. You can see here that this app call had some inner transactions. And that had some inner transactions, and that had. This is a cool one. Let's click on that. Now, there's a bit of a mic drop feature that we love is the transaction visualizer, which you can see here. And this is a cool one. I promise I didn't knew this was going to happen. That was a live transaction that happened a few seconds ago, right? Like. Ah, there you go. So you know all of it.
No, it's right in the...
Oh, yeah.
There we go. Fantastic.
Arc2 works.
And that's actually a really good example, right? So we've put all of these features in here to help developers, right? Like if you view an app and through the usual kind of conventions, in this case that there's a creation transaction note, we pull out the information. In this case, there's a DApp name in there so that we can actually see it, right? And so a lot of, like I say, a lot of what we're trying to do is make it easy to understand what's happening, easy to learn about the blockchain if you're completely new to it, or frankly, if you're experienced, as you'll see when we show you some of the wild transactions.
That we found.
It just helps you understand what's happening very quickly, very visually, and we've got lots of other ideas of wild things we want to do to it as well. But let's have a look at a couple of transactions, right? Like this one here is quite cool, that ORA, John's mum's
Has
oranges.
4 oranges?
Yeah.
Yep. Allegedly.
Which is in the description there, of course.
Yep.
Now, the cool thing is most of the pages in LoRa have a live transaction view, because what is happening when you run LoRa is it's constantly subscribing to the latest block. No matter which page you're on, if you move around, it's doing that, and it's keeping them cached, and it limits the cache size so it doesn't blow up your computer or anything like that. But that means that any page that you look at, pretty much shows up instantly unless you're searching for something that isn't in the latest blocks. But even those are very fast as well. And it means that as soon as something comes in that's relevant to the current page, we just show it to you. So if you're building something on your local machine, you're running transactions, you just want to see them as they come, you can look at that page against LocalNet and see them come in, and it's very cool. We're getting the, you're going too slow. So we're going to speed up a tiny bit and show 2 interesting transactions.
This one, acting on Patrick's feedback, we flattened the op-ups. So you can see here, this is an app call that interacts with a rekeyed address and then does a bunch of op-ups. It's at the beginning, whilst we were testing it, you would have ended up with like this amount of
This one's not rekeyed.
horizontal.
Is
I
this-
know,
That's
yeah,
a link
this one.
icon,
Okay.
yeah.
If it's on testnet, you can go to pool1.ready.algo and see all the rewards and epoch updates.
Nice.
Awesome.
We can try it.
We probably don't have time because Brian's going to kill us.
Yeah.
So, now this is a really cool transaction because this is a insane transaction, right? Like this account here is being.
Let's first show it as a
rekeyed.
table.
Oh yeah. Okay. Cool. Sure. Here's the table view of that. Like it's kind of hard to understand what's happening, particularly because this account here is sending all these transactions, but it's not sending them. It's actually the app that it's rekeying itself to this app here, and that app's sending on behalf of that account. And we can actually show that there because you can see there's a 1 there and a 2 there, and you can see like which account is actually sending it, but it's from the app itself. And as you can see here, when you hover over one of these things, you get all of this other information, and you can go and
So AAC, so GAW rekeyed itself to AAC as part of that call.
I think that one rekeyed itself to that. Probably.
Well, yeah.
Either way. Either way. The
probably-
point is, that's a wild transaction, but here it's like easy to understand what's happening, right? All right, so we're going to go back to the slide deck. That's Laura, which we're very excited about. There's a bunch more stuff we're going to add to Laura.
Yes, definitely. We've taken care about the Explorer part. You can point it to LocalNet, it'll work. Now we're starting to gather feedback and ask people what they want from an interaction with the smart contract standpoint. So, as always, we're on Discord. Whatever your dreams are, let us know. We'll try to make them true. And
The last thing we're going to show,
yeah,
right?
the nice thing about LoRa is that its beating heart is one library. We've briefly announced it whilst it was in alpha. We're talking about the subscriber library. So the subscriber library allows you to catch up either from AlgoD or from Indexer, pull in and subscribe to whatever kind of on-chain action you want.
In really, really terse, in this case TypeScript, although in the
Yeah.
future we will have Python
We are
as
working
well.
on the Python version.
But really terse like code that's easy for anyone to write. And you don't need to run like a follower node or anything like that. You can just point to any like
AlgoD
node that you
instance,
want
yeah.
to do. Yeah, exactly. And so we're going to show a little quick demo for that as well.
While you're loading up, quick question, does it support like fallbacks? One thing is really useful for NFT Watcher is I run non-archival nodes.
Yep.
And so
Right, it doesn't today.
Yeah, my watcher will check to see what the current block is for the non-archival and see if what it's trying to fetch is within its 1,000 block-ish range.
Oh.
And I'll fetch my non-archival node, which is local,
Yep.
in zone, like half a millisecond sort of response time. And then if for whatever reason, like the service got shut down or whatever, and it missed that window of where it's left off,
Yep.
then it will fall back to a public
To the index.
archival node
Okay.
until it gets within range and then switch back to non-archival for its blocks.
So
Yeah, so not today, but it wouldn't be too hard to add
that'd be really
fallback, right?
That's
yeah,
really useful.
yeah.
we
I
are,
agree
we're
with you.
doing
Yeah.
we're doing watermarking of blocks in case this happens, so that you can check against. So we're halfway there.
Yeah,
So
I
you
mean,
know
it's
what is the
built
last
to be
block
very
ingested.
resilient. So if the service, your service dies or whatever, and it comes back up, it'll pick back up from where it left. Like, and it processes every single like block perfectly. So there's two things we're going to show. One was we wrote some code. I'm not going to walk through the code because we don't really have time, but there's some code that we wrote that looks at the XGov voting app and actually sends the information to a SQLite database. In this case, using Prisma.
It would have been useful for your. Sorry, a few months late, but
and for a bit
now
of
you can.
So we ran through that like it caught up, like looked at the historical transactions, and in this case we did a little visualization of some of the voting so that we could kind of like see like some interesting information. So this is the sort of stuff that you can really easily do. I mean, it took me probably like a couple of hours to pull both that Prisma code and this Power BI together, right? Like this stuff is so much easier to do. But the exciting thing about the subscriber is the kind of liveness of it,
Yeah.
right? Like, so we've got some code here that looks at current USDC transactions. So we look for asset transfer transactions with that asset ID, which is the mainnet USDC.
Over $1.
And yeah, just to remove some of the noise, we've just said minimum amount is $1, right? And so we essentially then come down here and we say subscriber.on USDC. We're just going to log out that value, and that's the code. Like, that's it, right? And then if I hit F5 and we wait for battery mode to catch up,
Ooh.
and Node.js to be slow,
Yeah.
then what we will see, so we've set it to start off by looking at the latest 60 rounds. We're choosing this skip sync newest mode, which is one of many sync behaviors that you can actually do. And that skips to just the head of like the latest like tip of the blockchain basically and kind of keeps up with it, right? So you can see here we've just grabbed 30 blocks and then 30 blocks. And
So it goes to the newest, but then goes back 16.
in this case, yeah, it will start off by grabbing like 60, yeah, if that makes sense. And it kind of keeps there. So you can see here, like every single block is like detecting when that block happens, it waits for it and then immediately processes it. And like some blocks obviously don't have USDC, but if I scroll up a tiny bit, you can see there was a $71 transfer, there's a $34 transfer, there was a bunch here when we got the 60 at the start, including an $878 transfer. And yeah, so that's like, you can see it just live running and that's just Node.js code, like 20 lines of code, hit F5, like that's it. It's really, really, really easy to do.
And you can subscribe to balance changes, things on watching one address. You can do pretty much
that's a
whatever
good point.
you
There's a lot of really advanced functionality in there to make it a lot easier so you don't have to understand the raw blocks. So for instance, if you want to subscribe to any balance changes for either an asset or for algos for a given account, you can do that. Or you might subscribe to any transactions from a given account or whatever it is, and it'll tell you the balance changes from that transaction in there as well. And it handles all the things like asset closeouts and like creation of an asset means you get a balance added and all of this sort of stuff. So you don't have to worry. You don't have to know a lot of the internal details of how Algorand works. You get these really lovely payloads.
So we got a question in the session earlier. Could it watch the mempool for transactions that were not included in a block but may meet certain criteria?
It doesn't currently do that, no.
We only look at the block once it's there.
Yeah.
So
I was just going to say, I think it should also be noted that this is using a regular AlgoD node and not one in Pullover mode.
no, it's just simply your.
Yeah,
God
we
bless
called that
Algo
out.
node.
But yeah, exactly. Agreed. Yeah, so it doesn't need a follower node, indeed. So that's the stuff we wanted to walk through, and we'd love questions.
Yeah.
If there's time.
Question?
Comments?
Yeah, just a real simple question. So when you said the 60, did it actually, like the first block that it actually read and processed was 60 back or?
Correct.
Yeah.
Yeah.
No,
It's just saying go to the newest, but then you set a parameter to say go back.
Yeah. So the idea is like the number of blocks to.
Wait. So Patrick's question, because it won't get picked up by the mic, was the first block that it processed the 60 back, not the latest
It
one.
wasn't clear.
Yeah.
Is in some ways, is it basically like fetch 60 at once as a buffer thing and then process them, or
Yeah, so depending on the mode, so the key of the resilience of it is this idea of watermark persistence, right? So you'll start off with a watermark of 0 generally, and it will determine what that initial watermark should be based on the mode that you choose. So if you say skip sync newest, in this case, it'll skip to the newest, but like because you say, in this case, you say give up to 60 blocks at a time, it'll just go back 60. That number probably makes more sense when you don't skip forward, because if you start from nothing, you grab 60 at a time, like that's kind of the thinking. There's also a cool mode in there that uses indexer to catch up. So if you've got something that's been running for years and years and years, and there's a way of identifying certain transactions, like the Data History Museum is a good example, we know all of the assets that are created or modified by a particular account are the Data History Museum transactions. Linux Windows from the usual kind of task managers that you expect to be able to download them from, and it will run completely locally, and it will be able to do, are we going to drop any spicy alpha, or are we?
Yeah.
It'll be able to do, it'll be able to do cool things because it's running on your computer. You can listen to the file system, so it can watch for outputs from your compiler, right? Like there's an arc32 file. Oh, it changed. I can like do things with that, or I can read that in, so you don't have to go like upload file and like go in your file system. Like just make the developer experience so much nicer, right?
You need to parse args. Because I mean, it shows like the base 64 of the method arguments. Well, the first one is the hash.
That's the other. Yes.
So the hash
exactly.
Of the arg. Look that up, and then all the arguments should be parsed.
100%.
It should like be going to like on Ethereum before and like seeing every contract call and all that. I mean, it should be the same thing.
So for those playing at home, Patrick was saying, you can parse the base 64 bytes that are being put into the smart contract call, look at the arc32 and say, this is the method call and these were the arguments that were in it because you know the types. And yes, absolutely, that's on our list as well.
Exactly.
Which means that Explorer view that we saw that was already pretty good can be even better because when you've got the call to the smart contract, we can show the method that was called and the parameters that were passed into it.
On local net.
If you do ARM chain reverse lookup of NFDs, then it'll be even better.
Sure. Yeah.
It's in the works.
So it's really easy. I mean, I assume you.
No, we saw it. We've added to the backlog.
It's on the backlog, yeah.
Yeah. It's in, like the NFT CLI examples has all the code.
The other thing worth pointing out is LoRa is open source. And
yes.
So if anyone wants to go and look at how it was built, like it's very, very clean code. It's probably the cleanest like web UI code I've seen in quite a while. Like they did a really nice job. It's very cool.
He's biased.
I am biased, of course I am.
But it's
I didn't do it though.
It's
My team did it. But yeah, but it is very cool. They did a really like the reactive patterns to separate the like state change, especially with the background thing running to like subscribe to the chain and then flowing down into various pages. Like is very clean.
Yeah. What's the written name?
It's in React. Yeah.
And if you guys want to extend it, please feel free to contribute. We're open to any contributions.
In LoRa, the Explorer.
Yeah.
Yes.
Yes, it's picking up.
Never gets old.
Absolutely not when it's npm. But is the data cache first of all persistent and secondly shared between like tabs, or if I open like 10 tabs, it's gonna be like 10,
Yeah, I was wondering that because I had 4 tabs open. So the question was, the LoRa, is it persisting the data in a way that, A, is it persisting the data, and B, does it share the data between tabs, or is it separate data? I suspect it right now that it is actually per tab, but I could be wrong. I don't actually know off the top of my head. But it's a good question, and it's probably something we should look at because obviously developers are going to have lots of tabs open. Whilst each one maybe is limited to say 250 meg, if you've got 10 open, that's 2.5 gig. Not great. Definitely something we should do if we haven't already.
I've run 10 continuous tabs of it and no laptop blew up. But yeah, we need to check on that.
It's a good question though. I agree. Cool. Any last questions?
That's really cool, guys.
Thank you.
Thank you.
All right.